Swayam Prabha. Digital India. Educated India.
We will continue with Mohr circle in 3D. Last time we derived relations 1 and 2, which are as shown here. Number 1 is sigma equal to L square into sigma 1 minus sigma 3 plus m square sigma 2 minus sigma 3 plus sigma 3. And then we had also tau square plus sigma square minus sigma 3 square equal to L square into sigma 1 square minus sigma 3 square plus m square sigma 2 square minus sigma 3 square. Now, we would like to eliminate m square from these two relations, thereby we are going to get we will get now tau square into sigma 2 minus sigma 3 plus sigma 2 square minus sigma 3 square into sigma 2 minus sigma 3 minus, we will write sigma into sigma 2 square minus sigma 3 square. So, that is the left hand side, and the right hand side we are going to have L square sigma 1 square minus sigma 3 square into sigma 2 minus sigma 3 minus L square sigma 1 minus sigma 3 into sigma 2 square minus sigma 3 square. So, if we simplify, this can be simplified to get L square tau square sigma minus sigma 2 sigma minus sigma 3 divided by sigma 1 minus sigma 3 into sigma 1 minus sigma 2. So, this you can see that we will have sigma 2 minus sigma 3 cancelling out, and finally, we will have this simplification possible. So, by eliminating m square from 1 and 2 we got this, and we started with elimination of n square, and thereby we got relationship between L square and m square. We could as well eliminate from the beginning m square, thereby we will have equations involving L square and n square, and then again eliminating L square we can get n square, and this can be repeated for all the 3 direction cosines. So, you will find that we will get by a similar procedure we will get m square is equal to tau square sigma minus sigma 1 sigma minus sigma 3 divided by sigma 2 minus sigma 1 sigma 2 minus sigma 3. And n square tau square plus sigma minus sigma 1 sigma minus sigma 2 divided by sigma 3 minus sigma 1 sigma 3 minus sigma 2. Let us call these relationships. I want to correct this one as sigma 1 minus sigma 2, this is sigma 2 minus sigma 3. So, L square is given by tau square plus sigma minus sigma 2 into sigma minus sigma 3, and in the denominator we have sigma replaced by just sigma 1. Similarly, you will find same thing is repeated in the case of m square and n square. So, let us write these equations as number 3, this is 4, and this one is 5. These equations are really the basis for drawing the Mohr circle. So, let us take these equations one by one. First of all, let us consider that we have a situation wherein the 3 principal stresses sigma 1, sigma 2 and sigma 3 are the 3 stresses at a point, and we assume that sigma 1 is greater than sigma 2 and sigma 2 is greater than sigma 3. So, therefore, the stresses are ordered like this. Now, if you look into the relation 3, it gives you L square tau square sigma minus sigma 2 sigma minus sigma 3 by sigma 1 minus sigma 2 into sigma 1 minus sigma 3. Since the 3 stresses are having relative magnitudes like this, it is clear that this difference is a positive quantity, this difference is also a positive quantity, and we know for sure that L square is going to have value 0 or something positive. So, this quantity is positive. So, if this is going to be positive, then it means that the numerator here has got to be either 0 or greater than 0. So, from the condition that L square is greater than equal to 0, we have this tau square plus sigma minus sigma 2 sigma minus sigma 3 is greater than equal to 0. Now, we can write this thing as tau square plus sigma square sigma into sigma 2 plus sigma 3 plus sigma 2 sigma 3 greater than equal to 0. Now, we can write this thing as sigma 2 plus sigma 3 by 2 whole square. Then we can subtract, we have added terms like sigma 2 plus sigma 3 by 2 whole square. Whole square, and then we will have sigma 2 sigma 3, and this is greater than equal to 0. Now, again we can rearrange. We have now sigma 2 plus sigma 3 by 2 whole square, and this we can take it to the other side, and we will have now we can write this thing as sigma 2 minus sigma 3 by 2 whole square. So, this quantity you can surely combine with this, and you are going to get this expression. Now, this indicates an important condition. It says that the stress tau and sigma which are acting on a plane passing through the point, that is going to lie on a circle of radius sigma 2 minus sigma 3 by 2 whole square, and whose center is located on the normal stress axis at a distance sigma 2 plus sigma 3 by 2. I would like to explain this further. Let us consider now that we have we will like to draw the stresses like this. We would like to plot our normal stresses in the x direction. So, let us plot the normal stresses in this x direction. So, this is the normal stress axis, and then we would like to plot the shear stresses so shear stresses in this vertical direction. Now, what it means, let us now also write the stresses, that this is my stress sigma 1 and this is the stress which is sigma 2 and this is the stress which is sigma 3. So, for the point, all the tau and sigma that we are going to get, it is going to lie, when this is equal, it is going to lie on a circle of radius sigma 2 minus sigma 3 by 2 whole square, and whose center is located on the normal stress axis at a distance of sigma 2 plus sigma 3 by 2. So, therefore, if we consider this is the center of sigma 2 plus sigma 3, and if we draw a circle with this radius, distance between these 2 points, then we will have this circle. So, this is the circle which is having center at sigma 2 plus sigma 3 by 2 from the origin, and this radius is sigma 2 minus sigma 3 by 2. So, therefore, this condition indicates that the stresses on all the planes passing through the point is going to lie either on the circle or outside this circle. So, these are the look I am sorry, all the points are going to lie either on this circle or outside. Now, we will consider further, if we consider now the relationship which we have obtained for M, we have M given by m square tau square sigma minus sigma 1 sigma minus sigma 3 divided by sigma 2 minus sigma 1, and this is sigma 2 minus sigma 3. So, this is what we had got as relation 4. Now, again if you look into, we know that m can have value either 0 or positive value. This is m square is always going to be positive, 0 or positive, and this sigma 2 minus sigma 1, sigma 2 is here and sigma 1 is here. So, this quantity is negative and sigma 2 minus sigma 3 is positive. So, therefore, this denominator is negative. So, if this is going to be positive, then this numerator has got to be 0 or less than 0. So, therefore, for m square positive, so m square greater than equal to 0, we will have this tau square plus sigma minus sigma 1 sigma minus sigma 3 greater than equal to 0. I am sorry, it has got to be, if m has got to be this, then we find that this has got to be less than equal to 0. This should be the case. So, since this is negative, this has got to be negative or 0. So, now if we do little bit of manipulation on this like the one we had done earlier, you will find that from this relationship we will get tau square sigma 1 plus sigma 3 by 2 whole square is less than equal to sigma 1 minus sigma 3 by 2 whole square. So, this relationship indicates again, when we have this equality, it means that tau and sigma on all the planes passing through the point is going to lie on a circle of radius sigma 1 minus sigma 3 by 2 whole of radius sigma 1 minus sigma 3 by 2, and its center is located at sigma 1 plus sigma 3 by 2. So, sigma 1 is here, sigma 3 is here. So, the midpoint is here. So, therefore, the point is going, all the stresses are going to lie on the circle or within the circle. So, therefore, we can now draw the circle which is going to be showing the spread of all the tau and sigma. So, this indicates that all the points, all these combinations of stresses and stresses are going to lie on this circle whose center is here and radius is this. It is on this circle or within the circle. Now, we will take the third relation, which was 5, and this 5 was involving stresses. All in the numerator it was like this, sigma minus sigma 1, sigma minus sigma 2, and in the denominator it was sigma 3 minus sigma 1, sigma 3 minus sigma 2. Now, this is going to again give us, since n square is going to be greater than equal to 0. Now, sigma 3 minus sigma 1 is negative, sigma 3 minus sigma 2 is also negative. So, this is positive quantity. So, therefore, if n square is going to be 0 or positive, the numerator has got to be 0 or positive. So, therefore, this gives us tau square sigma minus sigma 1 sigma minus sigma 2, it is going to be greater than equal to 0, and if we again rearrange, this gives us tau square sigma minus sigma 1 plus sigma 2 by 2 whole square greater than equal to sigma 1 minus sigma 2 by 2 whole square. So, this indicates that when the stresses are lying on this circle, the circle would have radius of sigma 1 minus sigma 2 by 2, and center is at the center of sigma 1 and sigma 2. So, therefore, if we again consider now our circle again. So, sigma 1 is here, sigma 2 is here. So, this is the center of the circle, and then the circle which is going to give the dividing boundary is drawn with a radius of sigma 1 minus sigma 2 by 2. So, this indicates that all these stresses are going to lie on this circle or outside the circle. So, therefore, the stresses on all the planes passing through the point is going to lie in the space bounded by the 3 circles, and this is the space which will be occupied by all the stresses. So, this is the Mohr circle space in 3 dimensions. Or stress space. So, you should be now in a position to draw the Mohr circle in 3 dimensions. What is needed then? The steps should be that you must have your stresses should be known at the point the stress tensor sigma ij, then you calculate the principal stresses sigma I is 1 to 3, then you select your coordinates sigma and tau, locate the points sigma 1, sigma 2 and sigma 3, then draw 3 circles with center, first one with center at this center of sigma 1 and sigma 2 and the radius sigma 1 minus sigma 2 by 2. Second one you draw with the center at the middle of sigma 2 and sigma 3 and with radius sigma 2 minus sigma 3 by 2, and the third one is having center at center of sigma 1 and sigma 3 and the radius is sigma 1 minus sigma 3 by 2. So, this is the way you can draw the Mohr circle in 3 dimensions. Now, the question might be asked, how do we find out the stresses on a plane whose direction cosines are given with respect to the principal directions. So, let us now consider determination of sigma and tau on plane with the direction cosine L, M and N. Now, for this case, we draw the Mohr circle. First of all, you select your axis, this is the sigma axis, this is the tau axis, and then we have this, say sigma 1 is here, sigma 2 is located here and sigma 3 is here. So, this is sigma 1, this is sigma 2 and this is sigma 3. Now, we draw the 3 circles. So, now let us consider that n is equal to cosine gamma. So, angle gamma is known. Now, we consider we draw a line at an angle of gamma with the normal stress axis. So, we draw a line here at an angle of gamma with the normal stress axis. So, this angle is gamma. Now, we draw join the 2 points, these 2 points. So, let us consider this is A and this line intersect at the point B on the larger circle, and this point, let us say it is C. Now we would like to join this point to this sigma 2 point, or this point, let us say this is E. Now let us identify the centers of this circle as this is center O1, this is the center of sigma 1 and sigma 3 is O2, and this is the center of sigma 1 and sigma 2, this is O3. And now we will do little bit of constructions. We will try to now drop a perpendicular from this point on the normal stress axis. So this is F, and this, if I consider this O3B, we consider joining this O3B, and we also join these 2 points, and now we draw an arc with this as the radius. Now since this is semicircle, CBA is semicircle, and this is on this circumference and AC is the diameter, so therefore this angle is 90 degree. Similarly, you find that E to this point is going to be normal to this straight line because this is the diameter. So therefore this straight line and this straight line, they are parallel, and therefore this is also going to make an angle of gamma with the normal stress axis. So therefore this is also gamma. Now we would like to show that all these stresses which can satisfy this n equal to cos gamma is going to lie on this circle. Now let us consider that the stress on the plane that we are trying to find out, their normal stress is sigma and shear stress is tau. Now I would like to show you that all the stresses that can satisfy this condition is going to lie on this circular arc. Now let us consider the triangle ABO3, and this is the triangle that I am talking. This is the acute angle, and therefore BO3 square is equal to O3A square plus AB square minus twice O3A into AB into cosine of the angle gamma. Now you can see that O3A is nothing but sigma 1 minus sigma 2 by 2. So sigma 1 minus sigma 2 by 2, and this AB, this distance AC is sigma 1 minus sigma 3, and if I take the cosine of that, so that will be sigma 1 minus sigma 3 cosine gamma, that is the AB. So therefore sigma 1 minus sigma 3 square cos square gamma is AB, and then we substitute twice O3 as sigma 1 minus sigma 2 by 2 and AB as sigma 1 minus sigma 3 into cos gamma, so that gives us cos square gamma. So that is the expression. Now let us consider the triangle FBO3. So this is a right angle triangle. So we can write BO3 square is equal to O3F square plus FB square, and now we can write for O3F, it is nothing but O3F is nothing but this, if we consider the coordinate of this point as sigma and tau. So, this distance is sigma from the origin to this point is sigma, and the center of this circle is sigma 1 plus sigma 2 by 2. So, therefore, if we subtract, it is going to be sigma minus sigma 1 plus sigma 2 by 2 whole square, and Bf square is tau square. So, now if we couple these two relationships A and B, so we can write for BO3 square as this one, that is BO3 square, and that will be equal to the right hand side, which can be simplified to get sigma 1 minus sigma 2 square, sigma 1 minus sigma 2 by 2 square plus sigma 1 plus sigma 1 minus sigma 3 into sigma 2 minus sigma 3 cos square gamma. So, therefore, coupling A and B, we have this expression. So, now this can be further simplified and you get tau square plus sigma minus sigma 1 plus sigma 2 by 2 whole square. I take this thing to the left. So, therefore, it is minus sigma 1 minus sigma 2 by 2 whole square is equal to sigma 3 minus sigma 1 into sigma 3 minus sigma 2, and cos square gamma is nothing but n square. So, therefore, we get n square equal to tau square plus sigma minus sigma 1 into sigma minus sigma 2 divided by sigma 3 minus sigma 1 into sigma 3 minus sigma 2. So, therefore, you see that we get the expression for n that we have derived it during the construction of Mohr circle in 3 dimensions. Now, I would like you to note one point, that if I consider the stress to be given by any other point on this arc, and if I consider this distance, this radius, that is also going to be given by that will form a triangle. So, if I join the obviously BO3 distance will still be given, it will remain the same. So, that expression will not change, and we can have this same expression obtained starting from any other disposition of the stress. So, what I am saying, that if you consider this radius, that is same as this radius, and therefore, this expression that we have derived will not change, and therefore, even if this sigma and tau is lying at this point, it is going to satisfy the same type of relationship, and we will actually have n square there given by this. So, therefore, stresses are going to lie on this arc. So, we have seen that any point on this arc is going to give rise to finally a relationship of this type. Therefore, all these points are viable points satisfying the condition here. And in order to arrive at it, let us summarize what we have done. We have drawn the 3 circles from the given data, then we have taken the angle gamma here, drawn this chord, then joined these 2 points that intersected this circle at this location, and then we have drawn a circle with radius given by this. So, that is the circle which is really giving all the combinations of sigma and tau which will satisfy this relationship. Now, we are not yet sure about the values of sigma and tau. So, now we have to make use of the other direction cosines. So, now let us consider again our 3 circles, and let us now consider the direction cosine m, and let us say that is equal to m is equal to cosine beta. So, therefore, this beta angle can be obtained. Now, what we do is that we try to draw a chord with this point at an angle beta with the normal stress direction. So, therefore, we draw a chord here which is at an angle of beta. So that is the chord we draw. Obviously, if we consider that this is A, this is B, let us draw this line B to this point. We had indicated this point as E. So, therefore, BE and BA, they are at right angles to each other. Let us just write these stresses. This is sigma 1, this is sigma 2, and this one is sigma 1. Let us say that this is C again. And the center of the circles are shown here. This is O1, this is O2, this circle is O3. Now, we also draw a line here at an angle of beta with the normal stress direction. So, therefore, let us draw this line at an angle of beta again with the normal stress direction. And now, if we draw a line joining these 2 points, they are going to be again at right angle. So, this is a right, this angle is 90 degree. This circular arc, we draw a circular arc with O2 as the center and O2B as the radius. So, therefore, we draw a circular arc wherein this is the radius, O2B is the radius. Again, this point, let us say that the stress at this point is sigma and tau, and now we draw a normal from this point onto the stress axis. Let us say that is equal to F, the foot of the normal is F. Now, this construction will make use of to derive expression for m square now. Now, let us consider the triangle again ABO2 . We consider the triangle ABO2. From this triangle we have O2B square. Since beta is an acute angle, we have O2B square is equal to O2A square plus AB square minus twice O2A into AB into cosine beta. Now, O2B is nothing but sigma 1 minus, this is the center of the circle, sigma 1 plus sigma 3 by 2. So, therefore, it is going to be sigma 1 minus sigma 3. So, therefore, this distance is nothing but sigma 1 minus sigma 3 by 2 square, and we can get AB. This is sigma 1 minus sigma 2. So, cosine component of that will give me AB. So, therefore, it is sigma 1 minus sigma 2 cos square beta minus, we substitute the value of O2A and AB, that gives us this relations. Now, again, if you consider the triangle O2FB, consider this triangle O2FB, then you have O2B square is equal to O2 to F, that distance is nothing but sigma minus sigma 1 plus sigma 3 by 2 whole square, and the height FB is tau. So, therefore, that is tau square. So, please note that this distance is nothing but this distance is sigma, from here to here is sigma and here to here is sigma 1 plus sigma 3 by 2. So, therefore, if we subtract, it is going to be sigma minus sigma 1 plus sigma 3 by 2 whole square plus tau square. Again, if you consider that these two relations, let us say that these relations are C and D, combining C and D, we get tau square plus sigma minus sigma 3 by 2 square is equal to sigma 1 minus sigma 3 by 2 whole square plus sigma 1 minus sigma 2 into sigma 3 minus sigma 2 into cos square beta. So, this can be further written in a simplified form, and this will give us now this expression, and on rearrangement we get m square equal to tau square plus sigma minus sigma 1 into sigma minus sigma 3 into sigma 2 minus sigma 1 into sigma 2 minus sigma 3. So, therefore, what we find is that the stress point beta, I beg your pardon, stress point B satisfies the relationship, and now if we draw any arc with this as the center and this as the radius, it will also satisfy the same condition, and therefore, this is the other arc on which the possible combination of sigma and tau will lie. So, therefore, now we have got two arcs, and if I now try to superpose these arcs on the earlier one, so we will get this. I would not like to go the construction, show you the full construction, but I will draw that arc that we have obtained from the second constructions. So, I will just try to, this construction we have got from M. So, this is from N and this is what is from M. So, therefore, if I draw that arc that we have got in the second case, it is like this. So, this is the intersection of the two arcs, and therefore, that is going to be the point which defines the stress required on the plane with direction cosine L, M and N. And it can be shown very easily that, so I think you have got the intersection of the two arcs that gives the stress, and in fact, you are going to see that if the direction cosine L is also taken, L is also considered, L let us say that is equal to cos alpha. So, if we take L as cos alpha, then your construction would be like this. So, this is the circle. So, what you do is that you draw a line here with this as the angle alpha, then this straight line is also going to make an angle alpha, and with this as the center, with O1 at the center, if you draw the circular arc of this radius, that will give the combination of stresses which will satisfy this relationship. So, therefore, this becomes the another arc which is also going to satisfy the condition, or it will satisfy the required conditions, and therefore, you will find for sure that when these three arcs are superposed, this third arc I will also superpose it here, it is going to be like this. So, this one we had got, this first one we had got from the consideration of N, the second one we have got from the consideration of M. So, therefore, this is from the consideration of N, then we have got this from the consideration of M, and the last one that we have got is from the consideration of L. So, therefore, all these arcs are going to intersect at a point, and therefore, this is the unique point which is indicating the stress on the plane with direction cosine L, M and N. So, you can now solve problems involving determination of stresses on any arbitrary plane which is given to you. Let us then consider one example wherein the state of stress was given in terms of a tensor involving 9 components, and the principal stresses and their directions were determined. Let us consider that this is the principal stress direction 1, this is 2 and 3. The magnitude of the two principal stresses sigma 1 and sigma 2 are minus 200 MPa and sigma 3 is 600 MPa. So, in this case what is needed is that find out the stress on a plane which is making an angle of whose outer normal is making an angle of 30 degree with the sigma 3 directions and 60 degree with the sigma 2 directions. So, we are given the plane whose outer normal is approximately like this is the outer normal, and therefore, the plane could be which is normal to this could be this one. So, this is the outer normal which makes an angle of 30 degree. So, this is the angle which is 30 degree, and it is making an angle with the sigma 2 direction of 60 degree, and it is necessary to find out the normal stress acting on this plane and also the shear stress. So, let us now draw the Mohr circle. So, you select the two axes . Let us select the scale such that we have 1 centimeter is equal to 100 MPa. So, now in this direction we have sigma 1 and sigma 2. So, therefore, this is sigma 1 and sigma 2, and then sigma 3 is equal to 600 MPa and it is positive stress. So, therefore, it will be somewhere here, this is sigma 3. Now, since sigma 1 and sigma 2 have the same value, the Mohr circle which is to be drawn with radius sigma 1 minus sigma 2 by 2 has become a point. Now, we have to draw a circle with radius sigma 1 minus sigma 3 by 2. So, therefore, the center will be at the middle of this distance, and therefore, if we draw this circle, so this is the circle which is with radius sigma 1 minus sigma 3 by 2. So, now if we draw in this case n equal to cosine gamma, and if we draw a line at 30 degree from sigma 1 and sigma 2 facing sigma 3, so therefore, this is the line, Therefore, this is the point. In this case, again if we consider the circle with sigma 2 and sigma 3, so if we draw a line at an angle of 30 degree, that is going to be meeting the circle at the same point. So, therefore, this is the point that we are interested in, or this indicates the stress on this plane, which is given by the direction cosines like this, and therefore, the stress on this plane is going to be given by the normal stress is of this magnitude, and obviously you can calculate this distance. You can also obtain from the measurement. This comes out to be 400. Normal stress is 400 MPa, and this shear stress, which is given by this height, it is nothing but this is nothing but radius of this circle is 300, and you can note that this angle is equal to, this angle is 60 degree, and therefore, this is nothing but radius of this circle is 400. So, therefore, 400 into 10 sin 60, and therefore, this will give us 364 MPa. So, therefore, the stresses on the plane is nothing but normal stress is 400 and the shear stress is 364, and we have always of course made use of these as the two stress directions.